Oh,
Hey there, how's it going?
good. How are you?
Good. Just popped in here to see that it's working okay. It's running. All right.
Daniel.
Hey, how you doing?
Good. How's it going?
Pretty good.
That's good. How's it over in Ecuador?
It's pretty chill.
Yeah.
Not much going on.
Is everyone staying home?
Yeah, for
Yeah.
the most part. Yeah, how about you guys?
Same. Just being at home.
Yeah, looks like you're on a boat.
I am on a boat actually.
Oh,
Well, it's
nice.
a
Houseboat.
Yeah. I came
Living the dream.
Yeah, my parents. Yeah, I came to my parents so to not be completely isolated.
Oh, that makes sense. Yeah.
Okay, maybe I'll just do a little.
Looks like we got some people. I was worried nobody was going to come.
I just thought it was cool. Everybody putting their votes in.
Well, that's one thing.
Yeah.
Turning up is a different thing. Hi, Stephen.
Awesome.
Hello.
All right. Yeah, look at all of us. Sweet. So it's 2:30, so I'll just kick it off. And thank you so much, Daniel, for doing this. I figured doing all the virtual workshops, I know there's some probably super cool specific developer ones we could do. So thanks for volunteering, and I'll just hand it off.
Cool. Yeah. Thanks for giving me the opportunity to do this, because it's been a while since I've done a good talk on serverless. It's something I used to do more often than not. And thanks to everyone for coming to listen, because yeah, I thought I was going to be alone on this and everyone was just going to watch the recording or something, but everyone turned up, so that's good. Let me share my screen real quick. Helps if you're on slide 1. How do I get rid of this? Sorry, I'm just organizing my screen a bit here.
Would you prefer to see your audience or no?
It's up to you. I really don't mind. I've lost my window though, so that's the problem right now. There it is. Cool. All right. Please go back to full screen. There we go. All right. So my name is Daniel. I'm from Melbourne, Australia. I am a software developer. Been developing software for about 10 years, and about 8 of those professionally. Been working with serverless software since before AWS had API Gateway. It was back when they only had AWS Lambda, and none of the other cloud providers had any serverless anything that you could see. So it's been a while. Actually, not that long, because that was only 2016. It's just that serverless has come a long way since 2016. So what else? I've run serverless workshops quite a bit, as I said. Did AWS Summit Sydney. We had a workshop before that. And also Serverless Conf in Austin and New York City. I worked at a fully serverless company, which we believe at the time was the first serverless company, fully serverless company, which was a Cloud Guru. If you haven't heard of them, they're a cloud training provider. At the time, they were very small, but now they're quite big. And I was the first developer that they hired, so I helped build most of their LMS, which is totally serverless. What we're going to do today. So this is pretty much going to be, I know we have been calling it a workshop, but it's probably not long enough to do a workshop. Normally workshops go for like half a day to a day, but what I've tried to do is structure it in a way that I'll sort of run you through some of the code that I've written as part of the workshop. And then the workshop part can sort of be a little bit async, where I've got a Git repo, which you can pull down, and it's got different steps in it. And it's got a final step that you can develop yourself based on, analyzing the code from the previous steps. So what we're going to be building is a topical COVID-19 daily symptom tracker. It's nothing very extravagant. It's a very, very basic. It's just like a questionnaire with a single page, which has only got 2 questions on it. But if you wanted to extend on it and make it a proper symptom tracker, you could absolutely do that. Some of the features it's got, I tried to make these match the polls that we did in the Slack channel of what you wanted to see. So first one is the user can enter in their email on the sign up screen, and they'll receive a link to the current day's questionnaire. Then every single day after that, so long as they've got their notifications enabled, we'll send all the subscribers a daily link for the questionnaire for that day. I've written a example front end using Vue.js and Nuxt.js, but if you prefer to use something else, you can go in and write something else to hook up to the back end. And then on the backend side, this is obviously the serverless bit. We're going to be using API Gateway, AWS Lambda, DynamoDB, SQS, which is Simple Queue Service, CloudWatch Events, AWS Secrets Manager, and there's a few other smaller things that we'll be using along the way, like IAM, IAM roles, AWS CloudFormation for actually spinning up the stack of cloud services, I guess. So yeah, let's get started. So this is basically the architecture of what it looks like. It's pretty simple when you look at it this way. And the blue bit is the bit that I haven't implemented, which is kind of like the step 6, which you implement on your own. So you can basically look at the rest of the architecture that is built. There's examples there of how to spin up a Lambda function, how to use DynamoDB. So you just look at those and then build the rest of it yourself if you want to go ahead and do that at some point. I'll probably stay on for a little bit longer, just linger around on the meeting if anyone wants to actually try that now, and I'll sort of answer some questions, but I don't want to keep everyone around for like hours and hours and hours. So we've got a couple of things here. So the user would come into the REST API, which is built with API Gateway. That's that symbol there. Then depending on the scenario, we'll go to the right path for this one. So this scenario would be that they're putting in their email for the initial sign up. So that would be a specific route in the API Gateway configuration, which would then trigger a Lambda function, which is this symbol here. The Lambda function is just running a Node.js function, which will take the payload of that event and then do whatever functionality it needs to do, save the new user in the DynamoDB table. And actually, as part of this, it will send an email, which I haven't got an error here for, but I'm using a separate service called Mailgun to do that. You can use the AWS like email SMTP servers. I just find that they're pretty clunky and not so great, so I just haven't used that. And then we've got this daily cron job, which is actually not a cron job. It's a feature of AWS CloudWatch, which is you can set up events which are triggered by like a time interval, which is essentially cron. You can actually use cron syntax for it if you want. They've got an alternative syntax, which is a little bit friendlier than cron. So that's going to run once per day, call another Lambda function. That Lambda function will go and fetch the existing users from that table that we used before, filter it by people who have notifications enabled, and then it will queue up a whole bunch of emails to send onto an SQS queue, which is that symbol here. And then that SQS queue will trigger another Lambda function or a series of Lambda functions, because that queue will actually batch up all of the records into groups of 10. So if one Lambda container can handle that, then one Lambda container will. But if it has really, really high traffic, you might find that it'll spin up multiple instances of this this container here and run multiple functions simultaneously to send those emails. And then that Lambda function will use Mailgun as well. So yeah, I'll go through that. If you're interested in what these diagrams, where these diagrams come from, it's called cloudcraft.co. I find that they're really useful for this kind of stuff and for explaining to other people in your team if you're using AWS or any cloud things, what's going on. So if you wanted to follow along, you can go to this URL and download the Git repo. So I'll leave this up for like a couple of seconds. Actually, this short link service here is another serverless website that I built one time, which just has a database of mappings between these short link tokens and then the full URL, and does a redirect. That one's a pretty good use of serverless because you've got something that's there all the time, but you're not paying money for it if people aren't actually using it. Actually, I should go through some of that, what serverless is. So I might do that while I'm on this screen. So if you're not familiar with it, serverless is, doesn't mean that there's not servers at some point, because there are always servers at some point. It just means from the perspective of the developer or the team that's building the product, you don't have to concern yourself with running servers. So you don't have to SSH into machines and manage keys to those machines and updates and all that kind of stuff. This totally abstracts that away from you. And essentially what you're doing instead is you're running a whole bunch of different cloud services and hooking all the events up. As you saw in that diagram before, you hook all those events up. You sort of use Lambda as the glue between different services so that you can actually get your workflows done. So, I mean, that's essentially what you're doing. A lot of people sort of argue about what serverless is, and honestly, I don't think there's any point in arguing, because once you understand what it is, you don't really have to think about it too much. I mean, it is what it is. It is what I'm showing you, and you'll see more about it today. And I think a lot of the benefits of it sort of speak for themselves once you get there, especially around cost. This is a great back-end model for building startups because it's such a low-cost way of doing things. All right, so this is built up into 5 different steps, well, 6 different steps, but 5 different steps that I've already built, which you can look at as examples of how to use different services, serverless services. So step 1, by the way, all of these labels here, step/1, that coincides with a branch name in the Git repo. So the first step is just a bootstrapped front end and back end. There's no sort of functionality there. I think the back end has like a hello world function or something like that. Then step 2, I've created a user sign-in backend. So it's got an API gateway endpoint and a Lambda function that takes an email and then saves that person's user in the DynamoDB table, and then also sends them an email request or an email invite, I guess. Then step 3, that's the front end part of step 2. So that's just an online form, which I'll show you in a sec. Step 4 is the daily cron job event, which queues those emails onto the SQS queue. And then step 5 is actually consuming that queue and sending the emails. And step 6 is the DIY part. I should have removed the front end part from here, but I've built the front end side of it. So there is a form there that is ready to be submitted. You just need to do this step yourself if you want to, create the back end, and then enter in the URL and stuff into the front end to actually get it sending. It is worth noting that I need to put some better instructions in the README for this repo so that you can probably get set up. So I'm going to do that after this workshop. So if you were going to try it, probably don't try it just yet. There are some instructions, but not all of it. Cool. So that's my PowerPoint part of it. Well, it's not PowerPoint, but let's head over to the code base. So let me close all this so I can start from scratch. All right, so I'm not going to do step 1 because step 1 was just the bootstrapping of those frameworks. I mean, it's pretty simple. There's 2 folders there. We'll go to step 2. So in step 2, and I'm actually at the end of this, so I've got all of the code in there. So I'm just going to show you the relevant bit for each step. So that's this function here, send user entry email. So this code here will basically get bundled up when you deploy this, and it'll get it'll be the code that gets run in your Lambda function when it gets invoked. So when you're building a Lambda function, and there's many different languages that you can use, I use Node just because, most of the time I'm writing JavaScript, so it's easy just to use the same thing everywhere. But you can use everything from like Java to C#, .NET Core. There's just a whole bunch of options now, and that goes for other cloud providers as well. They have a lot of different options, but pretty much the common thing is that you usually have some sort of entry point to that Lambda function or some sort of exported handler function that's inside that code. So in here we've got exports.handler. This is the entry point that AWS will invoke our function through. So they'll send us a couple of things. They'll send us an event, and that event will contain information about the invocation, but it'll differ depending on what the source event was. So in this situation, we'd be getting an event from API Gateway, so it's a HTTP event. So that means that you'll see in there the kind of things that you'd expect from a HTTP call. So you'd have a body, you would have headers, you have like content length and that kind of stuff, similar things that you would see on like a web server if you actually inspected the logs of a request. So you can do things like parsing the body out into an actual JavaScript object. I mean, if you were using something else, you would have to do some sort of unmarshalling on that. And then we've got an example here of using DynamoDB. So I will go through how all of that is set up because I've actually used, there's something called the AWS Serverless Application Model, so AWS SAM for short, which is like a CLI framework as well as a cloud sort of definition thing, which you use in tandem to be able to actually write your cloud architecture or serverless cloud architecture on your computer and then upload it to AWS, and then they'll spin up all the infrastructure for you. So I'll go through how that table is set up in a sec. But in order to actually use that table, you would have a parameter. So that's this here. So you would have to give it a table name that you want to do your request to. And then you would have to, depending on the request type, so this is a GET request. So I'm going to just use a key. So this is sort of similar to like primary keys in a like a relational database, but it's a little bit different because DynamoDB is a document store, and it's I think it's based on Cassandra or something like that. So it has like hash keys and sort keys, and it doesn't. Yeah, it's a little bit different. So in this case, my hash key is actually email, and so I just put that as my key, and then I can essentially use the AWS SDK, which is a handy library that AWS has published. So if I go here, you can see how to use it. So they've published different libraries for all the different languages. This is the JavaScript one. So I just have to instantiate a document client, which is like a nice easy class to be able to access DynamoDB. So I'm using that here. And I basically do because it's asynchronous, I can actually await it. So that would send back to me whatever matching record that they have in the database. So you can check whether that item exists. And then, if it doesn't, we want to create it. So this is an example of a put request to DynamoDB. Same kind of thing, you just have to give it the table name, but in this case, you're not giving a key, you're actually giving the object that you want to save. So email created date, notifications enabled, and a token. I'll go through a bit of what I'm doing there with tokens a little bit later. So after all that, we would then just send the email. So I'm not going to go through this too much because this is Mailgun out of scope. But send the email, and then the next important thing is that when you're responding to an API gateway event from Lambda, you need to make sure that your response is in the format of like a HTTP response. So I've built a little helper library in Common Response. And so I'll just put in like the 4 sort of normal or most used ones. So 200 response, 500, 404, and 400. So what it's basically doing is it's sending a response object, which has a status code, some cause headers. Not going to go into that, but you need that to get your browser working. And then it'll serialize that JSON body, or if it's not a JSON body, I believe. Yeah, it'll just put the body there. And so that's like that's the format that API Gateway expects back from your Lambda function in order to be able to create the correct response to send back to the client or the user's browser. So that's basically a Lambda function. It's sort of very concise. There's not a whole lot going on there. Obviously, a couple of database calls, email send, but it's pretty small. Not a lot of like other stuff that I need to sort of do to get that working. And then if we go to have a look at this template.yaml, so this is an interesting AWS SAM sort of template, and it's based off of the templates that you would normally see when you're doing AWS CloudFormation. So for those who don't know, CloudFormation is like infrastructure as code. So you would define in there all your cloud resources, and then you would say, here you go, AWS, here's what I want you to provision for me in the cloud. And they would execute this template and provision all of that infrastructure for you, and then tell you when it's done. And then all of that will be logically grouped under what's called a stack. So you can sort of say, if I want to know, what's the cost of one particular application that I'm using, you can say, well, what's the cost of the stack that I'm actually, that I've deployed that under? And that will tell you like all of the resources that are bundled under that stack, how much it costs, as an example of why, why that's useful. But it also gives you a bit of like certainty around the state of your infrastructure in the cloud. So, if the stack is in a good state, then that means that most likely all of the resources under that stack are actually in a good state as well. correctly deployed, correctly running, whatever. And it allows you to manage your changes. So if you want to add new functions or new API gateway endpoints, you send it to AWS, they'll tell you, okay, we can see that you've changed these 2 things, and that means that we will do these 2 changes to your infrastructure. And you can say, oh yeah, that sounds correct, go ahead and do it, and then they'll do it. So it's got that kind of idea in it as well. So AWS SAM is like an extension on that. So most of the syntax here is more or less compatible, except for a few things with AWS CloudFormation. And a lot of the cool things you can do with AWS CloudFormation, you can actually do here as well. So things like referencing other resources within the same stack. So for example, if I do !ref email queue, which is referencing this queue here, that will actually return me the URL of the queue. So that's quite useful when you need to, for example, provision the queue and then pass the URL into the environment variables of your Lambda function in order to actually use the queue. So when you've got those sort of interdependencies between different resources, that's quite helpful. So let's have a look at the 2 things that were relevant to that that second step. So the first one is this user table here. So we can see this is a name that I can make up. So I've called it user. We tell AWS SAM that the type of resource this is AWS : DynamoDB : table. And then it expects then to have the properties related to that table. Now, understanding key schemas for DynamoDB is like a whole nother course on its own, because you need to understand how they will split up your data into different sort of clusters when they persist it, in order to understand what the sort of best key schema is for your querying patterns. So I don't really want to go into that. But in here, what I'm doing is I'm just saying that I have a key type hash, which I'm going to use my attribute email to actually populate that hash that hash key. And in order to do that, I have to actually say here that I'm going to have an attribute name, email, and an attribute type of string, which is S. And then I'm also going to have a secondary index, because your first index, your primary index, I guess, is the one that you define in your key schema, but then you can have additional indexes after that. So I'm going to have one here called notifications index. I'm going to have that based on a different attribute, but also using that as the hash key. So that attribute is going to be whether or not notifications are enabled. That's a number, 1 or 0. Yes, I'd like to have a Boolean, but it doesn't let you have Booleans here. And I'm going to project all of the data from the primary index into this secondary index as well. So that means that when I access the records here, I can also fetch all of the data that I had on the main record as well. And I can also say here that I want to have this billing mode pay per request. So you can either, with DynamoDB, you can say, I want to provision a certain amount of read and write units, they call them. So you can basically pay a fee every single month to have a guaranteed provisioned throughput for your table. In this case, I don't need that because that would just be expensive. So I'm just going to do pay per request. I will jump into the AWS console in a second, show you what this looks like in that side. But first I want to show you the function. So we have this one here. So this is the send user entry email. This one is type function. It depends on a couple of tables. So I've got the user table, and then there's another table, user date response. I need to tell AWS SAM where in this project the actual file lives. So the code is in functions, and then the handler is send user entry email, and then the index file, and then it's the handler function that's exported from that index file. And then I can basically say to AWS, I want you to run this function whenever these events happen. So the only event in this case that I need this to run for is an API request. So I've called this send user entry email. You can call it whatever you want. Said that the type is API. And then the properties are, I have to tell it the REST API ID, which is, as I said before, you can reference things. So there is actually an API resource here. So all I had to do is ref API, and that says, okay, get the ID of this API app here, and then, add a new entry point, or a new path, a new route, sorry, in that API gateway configuration. So that's going to be the route with the path send-user-email-entry, and it's going to have a method of post. And I'll show you what that looks like on the console side as well. And then I also need to tell AWS that this function needs to have certain permissions within AWS to actually do certain things. So one of those things is that it needs to be able to access another product in AWS called AWS Secrets Manager. So in AWS Secrets Manager, I've created some kind of like environment variable or like API keys that I need. So one of them, I believe, is the Mailgun API key that I need to actually be able to make requests to Mailgun. So I need the Lambda function to be able to request that information from AWS in order to, have everything it needs to run. And in the same vein, I also need this function to be able to run CRUD. Actually, I don't need this one, but I'll leave it there anyway. So I need it to be able to run CRUD operations against the DynamoDB table user. So this is actually really handy. I don't know if you've ever written IAM policies before, but they're a pain, such a pain to write. So these are actually policy templates that have been built into AWS SAM, so you can just reference them and then pass in a variable, and it'll build out the policy for you without you having to go and do all that yourself. So these are very handy. I love them. So yeah, let's go and have a look at the actual AWS console. So in order to do this workshop yourself, you will need to have an AWS account. And they do ask for a credit card before you start using it, but you should know that there are very generous free tiers on most of the products that I'm using as part of this. I believe you get like 1 million seconds of Lambda invocations every year that are free. And then when you pass that, they charge you a certain amount per minute of invocation or whatever. So it's pretty good. All right, so where should I start? Let's have a look at the DynamoDB table first. Okay. So these are the two tables here that were created by my stack. Oh, actually, let's go to CloudFormation first, because that's sort of like the starting point for where all this starts. So if I look at my stacks here, I've got a COVID-19 stack. All right, so here I can see all of the updates that I can see all the stacks that I've got, and then I've got all the updates that I've done to that stack. So that's quite cool that it keeps a history of like everything that you've requested for them to do with your stack. So, it goes all the way back to whenever you started. It tells you all the rollbacks and everything that went wrong. So it's a pretty good one for auditing. And then in here, it shows you all the resources that are part of that stack. So you can see that I've got an API gateway, REST API. I've got a SQS queue here, which is called email queue. Got a couple of Lambda functions. Got the this AWS events rule is the cron job that runs every day. Got roles, got other Lambda functions. So everything in here, yeah, here's the tables as well. Everything in here tells you basically what's like in this bucket, which is your stack that you've deployed as one unit. Okay. And then it also shows you can actually define outputs for your stack. So you can say down here, can you please save like the variables that are the outputs of these different resources, and then show that on the UI. And you can actually request them through the API and different things. Very, very handy. So I've said here, save the email queue URL. So let's put it there. I've got ARN. So ARN stands for Amazon Resource Number or Resource Name, I think. Yeah, Amazon Resource Name. So this is the resource name of the email function, the first one, I think. Yes. I've got the actual API URL here. I've got the ARNs of my DynamoDB tables. So pretty useful stuff there. And you can also see the full template that was deployed as well. Yeah. So this should, I believe, directly correspond to my AWS SAM. It's a little bit different. They've modified it slightly, but it's more or less the same as what's in my other one. So yeah, let's head back to the DynamoDB table. So in here, we've got the user table. So we can see here, for example, primary partition key is email, and that's type string. There's no sort keys, so it's just got a dash there. You can actually go and see the items in the database, and you can run queries against it. So you can actually do like query, which you can type in here like your, what email address you're looking for. You can add additional attributes that you want to filter on, sending, descending, etc. So it's a good place to come and just like debug and look at your data. Gives you metrics about actual usage of the table. You can set up alarms, capacity, all sorts of really cool things. This is my global secondary index, which is sort of like, my second. I've got a version of the query which has to look for users that have the notifications enabled. So I've set up this index to make that faster. Okay, and then we'll go and have a look at the API gateway resource. So we've got COVID-19 here. You can see under this, they've got a resources list. So you can see the route here, send user entry email. Post is the one that I wrote, which is actually going to go and invoke the Lambda function. And you can see sort of like how that works here. So the client will send a request, which is this. Then there's a thing, don't worry about this, but it's called Lambda proxying, which is an integration request, and that will go off to Lambda, and it tells you what function there. So if you click that, it'll actually go to the function. And then when the response comes back, I haven't got anything here because I believe because I use Lambda proxy, I don't need this one. And then it actually does the response to the client. And then there's this options one here, which is actually a cause pre-flight request, which is auto-generated for me. It just sends back the headers and the origins that are allowed. So if we head over to the function here, we can see, what triggers it. So they've got these pretty handy diagrams now. They didn't used to have this. So you can see what triggers your function. You can actually go in and see the code that was deployed. So I can see the entire package here. I can see all the common code that was deployed, the node modules. Actually, all of my functions are being deployed together just to make it easy, because it means I only need one group of dependencies. But normally you would only deploy the code that you need for the function that you're running. And then you can also see environment variables here as well. And then if you go to the monitoring tab here, which can take a while sometimes, you can see all sorts of stats. Hopefully there's something useful. No? Sometimes these graphs can be a little bit bad. So you can see duration of the time that your functions have run on average, minimum, maximum. You can see the number of invocations, error counts, et cetera, and you can click on this, which takes you to your logs from when your functions have executed. So this is like I guess your primary way of debugging these functions that run, because obviously sometimes they have bugs in them and they fail. So you want to know what's going on. So you can actually jump in here and you can see the logs and the timestamps of when those things were logged from the function invocation. So this is a good example of an error. Provided key element does not match the schema. So I would have to look at that. I think I've already fixed that. But at the end of each invocation, they'll tell you the duration of how long that function ran, how long they billed you for. So obviously they round it up to the nearest 100 milliseconds, I think. Yeah, so it was 2.7 seconds and they've rounded up 2.8 seconds. They tell you how much memory that function ran with and how much it used, 93 megabytes. So that can help you to, scale up your functions as they, get more complex. And what else? Init duration. So that init duration is how long it took for them to actually, or how long it took for your function to run, to start running. So from the time when they made the request for it to start running and the time that it actually started running. And that can be quite important because one of the big issues with serverless is that the time it takes for a function to actually start executing can differ quite a lot. So we have these cold starts where if the function is freshly deployed, which means there's no running container with that function deployed on it, then AWS needs to actually do that before they can invoke it the first time you call it. So that can sometimes get quite large. Sometimes you can be waiting 1 or 2 seconds for that to run before it actually starts, doing your code. So yeah, let me think what the next thing is that we want to look at. So I'll probably skip through a bunch of steps because I don't want to be here forever, but let's go through to the cron job and the other function that runs. So, all right, this one here, queue daily emails. So this one's pretty similar to the other one. It's a little bit shorter because we don't have to do as much checking. So the handler is here. So what we do here is we query for basically all the users in the system that have notifications enabled. So this one is a bit of an interesting query. So we have, we're querying not against the main index, we're querying against that secondary index, which is indexed by the notifications enabled. It's the same table, we just have to say that we're going to that second index. And then we can say that we want the notifications enabled to be 1, right? So this is expression attribute values. What this does is this will populate it's essentially a variable. So this notifications enabled is like your variable. So you can say, I want the notifications enabled column to be equal to that variable value, which is 1. So it's only going to give me those users. So I run the query, get the users, and then I'm going to loop through each user, call this function here, get the email request body or email request content, and I'm going to put that onto the SQS queue, which is pretty simple. You just have to serialize that body into a string and tell the SDK which queue URL that is. It's very, very simple. So then they will basically pop up in the SQS queue. So we can actually go to SQS here and see the queue itself. So it's this one here. All right. So they've got this tool here where you can actually poll for messages. So I can start polling now, but nothing's going to come through because there's no messages being sent at the moment. But if I were to poll here and send a message, it would come up in here. So that SQS queue has been configured to actually invoke a function, which I'll show you in a sec. So yeah, so this one's pretty simple. Yeah, just sends the response again, OK response, back to the, well, actually, in this case, it doesn't even need to do that. It just needs to not fail because it's not an API request. It's just a CloudFormation event. So if we take another look in this template here, we've basically got, oh, wrong one, this one. We've got here, this one here, queue daily emails. So that's that function that we were just looking at then. So this one depends on email queue. Does it actually depend on that? I don't think it actually depends on that in reality. So it's just pointing at its handler, and then this is the bit that we're interested in. So this one's got a different event. It's not an API event. This is a scheduled event. So this is the syntax that's nicer than cron. So you can basically say rate. You can say 1 minute, 5 minutes, 10 minutes, 1 day, 1 year. You can put whatever you want in there. Well, not whatever you want, but they've got some documentation that shows exactly what you can put in there. But it's pretty nice to use. Same thing here. We need to put some policies in. In this case, we've got a new policy, SQS send message policy. So obviously this function is sending messages on the SQS queue. So we need to have that available in there. Let's just go back over to CloudWatch. Some of these services for serverless are in weird places. Like you wouldn't expect the sort of cron rules to necessarily be in here, but they are. So if we go in here, we go events rules, and in here we can actually see that job. So here it's just fixed rate of 1 days. That's the schedule. And then you can see what it's invoking here. So if we click on that, that'll take us to the Lambda function it's invoking. And in here, you can actually see that, the reverse direction of that so that this is invoking this. And that should have a signature. Well, I haven't been running it very long. No data available. Wait, let's see if I do 3 days. There you go. So you can see I did a bunch of tests, which is why it was invoked like a heap of times. But if I were to change that rate to like every minute, then we would see like spikes every minute, So what's the next thing to look at here? Okay, and then there's the function that gets invoked by the queue itself. So that one's this one, send daily emails. This one's pretty small. So because we already put the request object for sending the emails on the queue, that means we already, we don't need to construct that here. We don't need to do any database requests. We can literally just take what's on the queue and send it to Mailgun, which is really simple. So that's what we're doing, just mapping through the records and then calling the send email and sending all the emails. So very simple. In this case, the event object has an array of records in it, or it has the event object itself has a field called records, and that's an array of all the records. So it's a maximum of 10 records, minimum of 1. So this one's a pretty easy one to work with. And if we have a look at the template for this, to see how that's actually invoked. So creating a queue is really simple in this. You just do email queue type AWS SQS queue. There are other properties you can add, but you don't need to because most of the defaults are really, sensible. And then this is the function that gets run from that queue. So actually, I got the dependencies the wrong way around. I think this one needs to be on this one here, because it depends on the queue existing in order to be able to be invoked by it. So the event here is type SQS, and then all you have to do is get the ARN of that SQS queue using the get attribute function. And it doesn't need any additional policies related to queues to be able to run. In fact, it doesn't need any of these, I don't think. I've just copied them from the other one, so yeah. And that's basically it for backend stuff. And then on the front end, I know this is not serverless, but it could be worth looking at how this works. I'll actually show you what it looks like. This is what it looks like. So if I bring my email client up, so if I type my email address in here, submit. I know it doesn't have a loading thing. Oh, what's going on? There we go. I think that's an example of a cold start. So obviously I hadn't invoked this function in a long time. So it took like a few seconds for that container to spin up and for the actual function to run and do, sending the email and then saving to the database, et cetera, and then finally getting back to my browser and saying, yep, I'm done. So if we have a look now, there we go. There's the email. Okay. And then in this email, there's a link, which takes me to the poll here. So I haven't done the submission part of this. This is the bit that you can play with if you want to actually do the workshop part. But let's have a trace of like what that did on the back end. So if we go over to over here to API Gateway, I don't know if we can see here any info. What's the date today? Why isn't that showing anything? Oh, here we go. Default. There we go. So we can see invocations here. It sometimes takes a bit of time to update. That's probably why there's not a tick just now, but there was a tick from when I was testing it earlier today. We can see latency on those. We can see the latency to the integration, which is a Lambda function. You can see errors 404s, or sorry, 400s and 500s. So if we jump over to the Lambda function here. So in here, we should be able to see in the monitoring, yes, it's got 1 hour, no data available. So it takes, this is the annoying part, is that it takes some time for it to actually update. But if we go and look at the logs, it'll be there. That's pretty much instant. All right, so there we go. So it's in your local time. So 5:16. Have a look here. So we can see the invocation. We can see, this is the actual request body. So we can see, what was the actual URL? What was the method? What are all the headers? Obviously there's a lot of garbage in here that you don't need to worry about because it's just HTTP stuff. But if you look down the bottom here, we've got the body, which was the JSON body, which has my email address in it. Then we can see here the response from Mailgun when I actually sent that email. So they said, yep, here's a ID for that. And we have queued it. Thank you. And then this is the response body, which I've just console logged out to be able to see, what happened.
Daniel, I'm not sure if you can see, but Stephen put a question in the chat.
I didn't.
Oh, okay, yeah. Sometimes when you're sharing the screen, it doesn't notify you. He said, is there an emulator you can use for faster feedback during development?
Yes. Well, it's actually not an emulator as such. They have actually built into AWS SAM the ability to download the current AWS Lambda container image and run it on a Docker container on your own machine. So I'll show you what that looks like after I've gone through all of this. But yeah, at the start of serverless, that was a real big pain point, is that you couldn't, it was really hard to actually debug things locally. But now they've made it quite a lot easier. So that's really, really good. So what else do you want to see here? Well, actually, yeah, I'll just go and do that now because unless I go and do the scheduled event one with the queue, maybe I'll set that up and do a deployment. That way you can actually see that part of it as well. So I'll jump into the back end here. I don't know if you can see that. Do you want me to zoom in? Anybody? No? Okay, I won't. So AWS SAM comes with a CLI tool. So that is just, the binary is just SAM. So with SAM, you can actually do a build and SAM deploy. So that will actually package up the entire of your backend application and then run the deployment. And you can actually see what it's doing in CloudFormation to make those changes. So the change I'm going to make is I'm going to jump in here and I'm going to change this to 1 minute. So it's going to run every minute. Hopefully not charge me too much money. So now it's up to the deployment part. So it's done the build part already. You can see build succeeded. So first it uploads your template and any changes to your functions to Amazon S3. and then they sort of sit there until the actual deployment needs to be done. So you can see here that based on the change I made, it needs to change change the permission, because I actually changed the Lambda permission further up in the template, and then it's also changing that schedule rule. So I can say, yep, I like that, and then it will tell me what it's doing as it goes through. So updating that. Usually it doesn't take too long, like a minute or so. But it can be, if you are debugging on the cloud, it can sort of be a little bit painful. That's the bit that kind of like, I think trips a lot of people up when they start using this compared to using servers, because it's not as easy as just, running debug or something on your IDE if you're actually doing that locally. But it does give you a more realistic sort of deployment environment, I think, because you're running it in the same sort of environment that you would your production instance in the cloud. So I have no idea why this is taking so long, so I'm going to just do some other stuff first. So we have a handy thing to run things locally. So first I need to run my Docker container. There are instructions in the repo on how to set this up. So I believe if you click on the AWS SAM link, this one here, and then click on your environment, so mine's Mac OS. So in here, it's going to run you through everything from start to finish. So they're going to help you create an AWS account, configure your permissions, install Docker, install Homebrew, which is a Mac thing, and then install AWS SAM itself. So if you just follow these Docker steps, that'll get you up and running for whichever environment that you're in. All right, here we go. So we can see here that it finished updating that rule. It does a bit of a cleanup. Yeah, not much there. And then it sends you the outputs again of your stack. So it's pretty handy. So now that thing should just start running over and over again. So we want to catch some of those events that are happening in SQS. So if we jump into there, open up this, and then start polling for messages, hopefully they actually occur. Actually, let's run this for 120 seconds for 2 minutes. That way we'll definitely catch them. So we'll come back to that once they're there. But first, let's have a play with the local invocation stuff. So I should definitely have saved them in a text file somewhere, because I don't remember exactly what it was, but it should be here. There are. All right. So here's an example of like the entry email, for example. So you always need to build whenever you've made a change to your code. Otherwise, if you do SAM, if you do this command here, SAM local invoke, it'll just invoke whatever the previously built version was. So when you're actually debugging, you need to build it and then invoke it. So you need to tell it which function you want to invoke. So this is when you're doing the direct function invocation version. There is a version where you can actually spin up the API gateway sort of emulated within your Docker cluster, and then just use it as if it was an API. That one might be more useful if you're doing like local debugging, because you can just point your local app at that API. But if you just want to run the function with like a sample event, you can do it this way. So you tell it what function it is, you pass it the path to the event object. So if we have a look at the events that I have up here. So I think it's this one, send email event. Yeah, so this is an example, just like a HTTP request that I've captured and then saved in here. And then I've changed the body to be, what I want it to be. And then you can also overwrite any environment variables as well. So I haven't checked this in, but you would put your environment variables into here to like override the ones in, like these would normally come from the stack. So they would normally be like pre-populated by AWS, but because you're running it locally, they're not going to be there. So you need to say like this function has these environment variables. So it's a little bit cumbersome, but I mean, once you save this command, once you've got it set up the way you want and save it, you should be fine. So I can just run that. It's going to build. Probably didn't need to do that this time, but. And then it will invoke it locally.
Hey, Daniel.
Yep.
Just letting you know, I have to jump off for a call.
Sure.
But you guys keep
No
going
worries.
as long as you want. It's not gonna cut off or anything. So
Yeah, I'll probably finish up soon anyway because I don't want to keep people too long. But
okay, just want to let you know. But thank you so much. You rock.
sure. Thanks. So in here you can see the same sort of output that you would see in the CloudWatch logs. So you can just see like the logged out request object. You can see request context and then any other console logs as well as the response and similar sort of thing with the invocation time, et cetera, et cetera. So that's a useful way to be able to do that locally. As far as actually putting breakpoints in that, I believe there is a way. I haven't tried it with AWS SAM yet. This is actually the first time I've used AWS SAM. Previously, I used Serverless Framework, which was like the one that came very early on, long before AWS SAM was built. So you can do that. And then I think there's SAM local. Let's see what else I've got here. So SAM local start API and see what that does. All right, so you can now browse to the above endpoints to invoke your functions. You do not need to restart or reload SAM CLI while working on the functions. Change will be reflected instantly or directly. Okay, so this one's good because it's going to rebuild your code for you. So you can basically, well, I wish that it hadn't started on the same URL that my other application had started. Oh, is the other one not running? Yeah, the other one's not running, so that's fine. If I close this, then that will stop that from happening. So say we did go to, well, it needs to be a post request. So let's use a REST API client. So this one's called Postman. So that is running. So we can basically set up this. We can say post. We can say localhost 3000 send. What is it? Send user entry email. We can say that the body is JSON. And I believe it is email. And then I'll send it to my email. It should just work, hopefully. I'm not forgetting anything. Server timeout. Yeah. Oh, okay. So something went wrong. Requested resource not found. So yeah, I mean, it did run, but it failed for some reason. So I would have to look into why that resource isn't available. Maybe because I changed the permissions or something. But yeah, that's probably the best way to run it locally is to use that API, SAM local start API, and that will just give you all your API endpoints there. But if you wanted to test, for example, the SQS function, this wouldn't work because that's not attached to the API. That's just attached to SQS. So you would need to either invoke that function locally directly, or you would need to put something on the SQS queue to actually get that function to be invoked. And for some reason, there weren't any messages on the queue. So I don't know why that would happen, but there definitely should have been. So yeah, I might leave it there as far as like going through things. So if anyone has any questions, I can probably take those now.
I was just wondering if you had the link again for the GitLab that you posted before.
Yes, I do. It's this one here.
Thanks.
I just wanted to say thank you, Daniel. That was a lot of fun. That was a good tour.
No worries. Yeah, it's a difficult one as well. Like, kind of like trying to like rush through a lot of assumed knowledge, I guess, as well. Sorry if I sort of skimmed stuff a little bit too much. It's easy to do that, I think, when you're familiar with something, I guess. So if you do have any questions like afterwards about AWS or setting up accounts, or if you do try and do this, I mean, as I said, I'll update that README to make sure that all the information's there for setting everything up locally. But if you do go and do this and you have any trouble, just reach out to me on the Slack channel, and I can help you out. But yeah, AWS can be a little bit of a beast. So if you do sort of jump into it and you don't know what you're doing, then try and keep at it, because it's a pretty cool platform once you get to know all the different things that are on there. If you do want to do it serverless, on another cloud, go ahead. Like, I'm not saying that AWS is the best. It was definitely the first one, but I wouldn't say today that it's necessarily the best one. I'm a big fan of the way that Microsoft has done it with Azure. Their way that they've done Cloud Functions or Azure Functions feels more natural to me than AWS Lambda. So if you are more familiar with like Azure, then probably go with that, because they have a lot of similar services to this. They have their own table storage, they have their own blob storage, they have their own queues. You can pretty much do everything on there that you can do on here. There will be some sort of edge case differences. There's a thing on AWS called step functions. I don't know whether they have something like step functions in Azure, but look, I've never really needed to use step functions. They're made for very specific scenarios, so it just depends on what you need to use. But if you've never tried serverless, I definitely recommend it, because it's pretty fun. But yeah, otherwise, thank you for coming to listen. So any other comments? No?
I would vouch that Google Cloud Functions for in the GCP space are a little clunkier than AWS Lambdas, at least as of a couple months ago.
Yeah. I mean, I haven't used Google Cloud's functions, but they purchased Firebase, and I did use Firebase a lot before they were acquired by Google, and they weren't too bad. They were pretty good. And you can actually see function as a service sort of appear in different places as well. Like if you go and use what's a good example? Like Auth0 have their own function as a service. So like you can actually trigger functions on different auth events as part of their library, or as part of their service. And then I think Netlify, which is the static hosting website, they also have their own functions as a service. So it's kind of cool, because like I reckon it's a pattern. Like it's a new pattern using like functions as a service, because it's something that we didn't really see a lot of before. I mean, there were similar things, like there were like stored procedures is kind of like one example of something similar to functions as a service that I can think of, but obviously it's really specific to databases, So, there's that, and then there's probably countless examples of something that's similar to functions as a service, but this is the first time I think that we've seen it be used sort of everywhere as a thing that you can just do, on different platforms. Super powerful. So, yeah. Is
All right,
anyone
very
just
cool.
out of interest?
How's
Just out of
everybody?
interest, is anybody actually going to try and do the workshop or not? It's fine if you don't. I just need to know whether I need to go and update it right now to have the README. I'll probably turn it into a video at some point, but anyway, that's enough for me.
I think this is a screen record, right?
Yeah, it is. Yeah.
All right, cool. Well, thank you so much for this workshop. It was so helpful. And I'm going to go ahead and let this process and put this up right after this. But this is your chance, Daniel, for you to share with us anything you're working on, anything you want to promote. or that you want to tell people about? Anything?
Look, I don't know. I mean, I've been planning on building a like a dev training website called Better Coding, but I still haven't got any videos up on there. So maybe this is a good chance to like use this as my first
Cool.
thing. Yeah. But no,
Totally.
nothing else. Nothing else.
All right. Well, thank you everybody for coming, and thanks for hosting. It was awesome. And we'll see you guys in the chat.
Thanks,
Bye.
everyone.
Thank you.
Take care.
Bye.